Alright, 4.2, day 2, looking at zeros of polynomial functions. Today's video is all about the complex numbers. We're going to kind of work backwards. Yesterday we kind of factored to find the zeros. Today I'm going to give you the zeros and you are going to have to write the polynomial. Okay, so think about that as we take a look. Let's get started. So first thing we want to look at, complex zeros. Hopefully you remember complex numbers are imaginary numbers. Okay, so what I'm about to write down, complex zeros, they will always come in pairs. So if a plus bi is a 0, then a minus bi is also a 0. The example that I gave you will absolutely help you understand that complex zeros will always come in pairs. So if positive 4i is a 0, negative 4i is also a 0. If negative 5i is 0, positive 5i is also a 0. Big one to write down. If 2 plus 3i is a 0, then 2 minus 3i is also a 0. Okay, so understand that they will 100% always come in pairs. Kind of get what I'm stressing to you. Always come in pairs. Remember that. Okay, so letter E, constructing a polynomial from its zeros. I ask you to find a third degree polynomial. So I know when I am at the end, this thing better look like x cubed, yada 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 yada. Okay, so it's got to be an x, if the third degree, it's got to be x cubed. So if it's x cubed, I know something before I even start. I know that there better be 3 zeros. Okay, so x cubed, third degree, that means there has to be 3 zeros. So if I think about it, it tells me that 3 is the only real 0, and 2i is also a 0. Well, if I know that, here's what I'm thinking. Well, positive 3, positive 2i, and also negative 2i needs to be a 0. Remember, they come in pairs, right? 2i, negative 2i. Guess what? 1, 2, 3. I said it was going to be a third degree, so there better be 3 of those. There are 3 of them, so it looks like I'm good to go. Okay, so think about it. If those are the zeros, what will be the factors? Okay, think about that. If those are the zeros, what will be the factors? Well, take a look. If positive 3 is a 0, that must mean x minus 3 is the factor. If positive 2i is the 0, that means that x minus 2i is the factor, and same deal. Negative 2i, then x plus 2i is the factor, right? 0 factor. Understand that. I think you got those. Not bad. So, alright, so there is my polynomial. Now it looks like all I got to do is simplify it from here. I don't know about you, but when I look at these first two, and I try to think about foiling those, that's going to be a nightmare that I don't want to handle. So the advice, I wonder, I'm going to take a look and I'm going to foil those two instead. Hopefully you remember how to foil the 2 of them. What can we say about the 2 of them? How do I foil? Well, first, outside, inside, last. Tell me, why did I only multiply the first and the last terms? I didn't multiply the inside and the outside. Why did I only multiply first and last? Hopefully you remember that they are complex conjugates of each other. When I know I have complex conjugates, I know I only have to multiply the first and the last. Voila, there it goes. That's why I did it. Okay, so from here, I'm going to simplify this thing a little bit further. I remember some things. I remember that I squared is equivalent to -1. So this whole mess right here basically says -4 times -1. Well, I think I know -4 times -1 is, well, +4. Okay, so maybe write yourself a note right over here. I squared is equivalent to -1. That's going to be important, and you know that this guy right here is multiplication, so multiply the two of them together. We should be good to go. Alright, so from here, simple. All I'm going to do is, now I'm just going to FOIL the two of them. So first, outside, inside, last. Okay, so I got that. Looks like I just need to clean that up a little bit. Alright, we always want to kind of write them in order. So if I do that, it looks like, voila, there's my answer. So if I were to, guess what? If I were to factor that thing, I would get this polynomial back, right? Kind of just working in reverse. So looks like I'm good to go. So there's my polynomial. One down, one to go. Right, next one, letter F. It says find a third degree. Okay, so again, same deal. I know there have to be 3 zeros. Find a third degree polynomial. -2 is the only real number, and 3i is also a 0. We'll talk about, I think I'm ready to talk about what this means now. Assume a equals 1. We're going to talk about that in a second. Let me kind of just go through the spiel. Alright, so what are your 3 zeros? Let's think about that. Well, -2, +3i, -3i. If those are our zeros, how would we write our factors? Well, hopefully you're saying something like that. I think I'm going to FOIL those last two again. How do I FOIL them? Well, I know they're complex conjugates of each other, so I know I only multiply the first and the last. I know that I squared is equivalent to -1, so this basically says -9 times -1, which is +9. Let's FOIL that puppy from there. First, outside, inside, last, and then let's kind of do a little bit of cleanup. And voila, looks like there is my answer. So let's talk about what this guy means. Assume that a equals 1. Basically what I'm telling you is I want you to assume at this point right now, I want you to assume that the leading coefficient, this number right here, it won't go. Okay, that's close enough. This number right here is assume that the leading coefficient is a 1. That's all that means. Okay, so hopefully that went okay. Not too difficult. It's just a bunch of foiling. Understanding that complex conjugate always come in pairs. That's something that you're going to need to remember. And yeah, good job.